All right, I understand that the YouTube has taken down my 2C video, so I'm going to remake it. Um, so we're supposed to differentiate this. And this looks like we have a product rule. So we got to take the derivative of the first, because the product rule says derivative of the first times the second plus the derivative of the second times the first. The derivative of the first, the derivative of 3x is 3. Derivative of 2x to the third, 3 times 2 is 6. X to 1 less power, 2. That's the derivative of the first times the second. You don't do anything to it when you put in the second. And now you have to take the derivative of the second. So the derivative of the sine is cosine of whatever's there times the derivative of the inside, what the cosine is of, or the sine is of, and that's 5x to the third. So 3 times 5 is 15x to 1 less power. So that's the derivative of the second times the first. And don't need to simplify. All right, we're supposed to find the derivative of this and then find the slope. Just find the slope of the tangent line. You don't have to find the tangent line. Just find the slope at pi over 2. So we have something squared. Inside the something we have tangent of something. And inside that is the x over 2. So this is a three-level chain rule. So the derivative of something squared, so f prime of x, we're looking at the big picture, was something squared. So the power comes down 2 times the something to 1 less power, which is 1. And that something was tangent of x over 2. Remember, when you're doing the bigger picture, you don't do anything to the inside. You leave that alone. So we did the power rule, 2 times this to the 1. Now we do the derivative of the inside, and that's tangent of something. Derivative of tangent of something. The tangent is secant squared. Secant squared of whatever's in there, and that's x over 2. And then the derivative of the inside. Well, that's x over 2 is the same as 1/2 x. So the derivative of 1/2 x is 1/2. So once again, we have something squared, so the derivative is 2 times the something to 1 less power. Then we have inside there a tangent of something, and the derivative of tangent is secant squared of the something. And then the derivative of x over 2, which is the same as a 1/2 x, the derivative of that is just 1/2. And so there's the derivative. So to find the slope, we have to put pi over 2 in for the x's. So now I'm going to do a little simplifying. Don't have to do this much here. You could just type this out in a calculator, putting pi over 2 in for all the x's. But I'm going to do the canceling here. 1/2 times 2 is 1. And pi over 2 divided by 2 is pi over 4. And at pi over 4, the tangent is 1. So we have 1 to the 1 times secant. Secant is the reciprocal of cosine. And at pi over 4, because it's pi over 2 cut in half, at pi over 4, the cosine and the sine are both square root of 2 over 2 when the hypotenuse is 1. And so the secant is 1 over square root of 2 over 2. 1 over the square root of 2 over 2, or the reciprocal of square root of 2 over 2, which is 2 over the square root of 2. And that is squared. And so we get 1 to the 1 power, or 1, times 4 over 2. So if you put pi over 2 in for the x's here, have your mode in radians, and type this into your calculator correctly. To type this in, you can type in 1 over cosine squared of x over 2 and put pi over 2 in there. And it should come out to give you an answer of 2. Number 3. Now we have to do, we've got a derivative of this y in 2 different places. Can't solve for y so easily. So we're going to do implicit differentiation. So the derivative of x to the third is 3x squared times the derivative of the inside, which should be dx dx, or 1. So I don't have to do anything there. Plus the derivative of y. The derivative of y to the 1 is 1 times the derivative of the inside, which would be dy dx. This is what you do when you have implicit differentiation. Equals, and we have 1/2 derivative of ln y. Well, the derivative of ln of something is 1 over the something times the derivative of the stuff inside, which would be dy dx. So I have 3x squared plus a dy dx equals 1 over 2y times dy dx. And to get the slope for this tangent line, I need to solve for dy dx. And it says to do it at the point -1, 1. Notice that if I put -1 in here, I get -1 to the third, which is -1. And I put 1 in there, I get +1 equals, and 0.5 ln of y of 1, ln of 1 is 0. So 0 times 0.5 is 0. So this really is a point on the graph. Now I could have left one of these out and asked you to solve for it, but I gave you both of them on this problem. So now to find the slope, I got to solve for dy dx. I can either right now bring this to this side, factor it out, and solve for dy dx, and then put in the -1 and 1, or I can put the -1 and 1 in right now. -1 for x. This would be -1 squared, which is 1 times 3, 3 plus dy dx equals 1 over 2 times 1, which is just a half. I still need to solve for dy dx, so I still need to get dy dx on the same side. So I'm going to subtract dy dx from both sides, and I get 1/2 of a dy dx minus 1 dy dx. That's this. Subtracting it from both sides, I can factor out the dy dx, and I get 1/2 minus 1 times dy dx equals 3. And 1/2 minus 1 is -1/2. So to get rid of this, I can multiply both sides by minus 2. And dy dx equals negative 6. So that's the slope of the tangent line. And using this form, y equals the slope at wherever we're interested in. Well, in this case, it's at minus 1 times x minus where we're looking at minus 1 plus f of where, oh, this is c in the equation, and we're going to put in minus 1 there, and f, the y value at wherever we're looking. And we're looking at minus 1. So the slope at minus 1 is minus 6, x minus a minus 6, plus the y value. Oh, wait a minute. We're interested in at minus 1. Excuse me. Minus a minus 1 is plus 1. Boy, I almost made a nasty mistake there. Plus the y value at minus 1, which is 1. Now, on this one, all we have to do is get the derivative. And this is a quotient, but there's some chain rules and other fun stuff in here. But it's a quotient. So we take the derivative of the numerator times the denominator minus derivative of the denominator times the numerator over the denominator squared. So derivative of e, derivative of the numerator, e to the negative 5x, derivative of e or anything to a power is it back, and times the ln of the base, but ln of e is 1, so, or the derivative of e to anything is e to the anything, times the derivative of that. And the derivative of negative 5x is negative 5. So we have the derivative of the numerator times the denominator You don't do anything with that. You just write the denominator. Now, we do the derivative of the denominator. So now we got to take the derivative of arcsine, of sine inverse. And that, according to the formula, is 1 over 1 minus x squared, square root, but x is 4x. So it's 1 over square root of 1 minus 4x squared, or 16x squared if you want, 4x quantity squared. But since this is more complicated than just an x, it's times the derivative of the inside times 4. That's the derivative of the denominator times the numerator divided by the denominator. Now, you don't do the derivative or anything, just the denominator, sine inverse or arcsine. I could write arcsine here and here, but I'm just going to write sine inverse of 4x. That, whatever that is, squared. There's the answer. Number 3. If you have to do the derivative of this, it's a product rule. And if you're trying to do it from minus 5 to minus 1, it won't be, you can't do the derivative there because ln is not defined from negative numbers. So, determine whether this function is differentiable over this it. It is not differentiable because ln of negatives are undefined. Now, if this had been ln of a negative x, and we were putting negative numbers in, then it would be defined, and we could do the derivative. Now it says determine the slope of the tangent line at 1.5. Well, it's defined there, so we can do the derivative. So the derivative of a 4 to the x, that's something to a power x, is 4 to the power, same thing, times ln of the base. So that's the derivative of the first times the second plus the derivative of the second, derivative of ln is 1 over x, times the first. And if we're trying to find the slope of the tangent line at 1.5, we put in 1.5 in for the x's. And so the slope of the tangent line is going to be ln 4 times 4 to the 1.5 times ln of 1.5 plus 1 over 1.5, 4 to the 1.5. And you can type that into a calculator and get decimal approximation. I'll do that just so we have it, just in case you want to try. So I'll slide this over there and type in ln 4, close parenthesis, 4 to the 1.5, ln 1.5, close parenthesis, plus 1 divided by 1.5 times 4 to the 1.5. And the slope of the tangent line is 9.83 at 1.5. An object is thrown straight up at 105 feet per second. That's why this is 105 t. From a height of 60 feet, that's why that's 60. Starts at 60, going up at 105, and losing at 16 feet per second every second. 16 feet per second every times the time. But the main idea is the position or the height or the distance something traveled, its derivative, since this is in feet, and the derivative finds the slope, it would be feet per, because that'd be the change in y, over the change in t, and t is in seconds. So h prime of t is the velocity equation, and the derivative of negative 16t squared, you take the 2 down, that makes negative 32t to 1 less power. And the derivative of this is plus 105 t, the 1 comes down and makes t to the 0, which is 1. So you're done there, and the derivative of 60 is gone. So there's the velocity equation. Acceleration is the derivative of the second derivative of the position equation, or the derivative of the velocity equation, and that gives you the acceleration. And the derivative of this is negative 32. Turns out it's actually 32 feet per second squared, because this is in feet and seconds. But you don't have to put the units on the equation. But when I ask you what is the velocity, I do want the equations at 2 seconds, which means you put 2 in here, and you get negative 32 times 2 plus 105. So that's negative 64 plus 105, which is 41. And in this case, everything is in feet and seconds, so it's feet per second. And now the last problem. Oh, and I have a bonus questions on here. Yeah. On this one, I had a bonus question. I probably won't put that on the test, so we'll just leave, not do that. But basically, you would follow what we did in class on that big, longer sheet in there. Maybe I will do it. We'll see here. But let's do this one. We have to find the derivative of 2 times g of x, f of 2 times g of x. So we've got a function inside a function. So we have to do chain rule. The derivative of the big picture is f of something. So it's f prime of the inside. We don't do anything when we take the derivative of the big picture of something. It's f prime of whatever's inside, 2g of x, times the derivative of the inside. Now you might think this is a product rule, but that's just a constant. So it's 2, derivative of 2 times something is 2 times the derivative of the something, and that's it. Now, if you had used the product rule on the inside, you would get the same thing, because you would do the derivative of 2, which is 0, times g of x, derivative of the first times the second, plus the derivative of the second times the first, and notice you get 2 times g of x plus 0. So you could have used the product rule, but it's this. Now, we want to actually find the slope using this table and the central difference theorem. So we're supposed to find the slope of f at this place, at this value, and x is 1.4. So we're trying to find the slope of f at 2 times g of 1.4. Well, 1.4, g of 1.4 is 0.7. So 2 times 0.7 is 1.4. So 2 times g of 1.4 is 0.7, so 2 times that is 1.4. It took us right back to 1.4. And this is times 2 times the slope at 1.4. The slope of g. So we go to g and we go central difference theorem, which means we do just past it 0.67 minus just before it 0.74 over just before it in the x, change in y over the change in x, 1.5 minus 1.3. That's just be after 1.4 and just before. That's g prime doing the central difference theorem, times 2, and f at this place, we have to do central difference of that. So we need the slope of this. And f near 1.4 would be 0.63 minus 0.71 over 1.5 minus 1.3. That's this times 2 times this. So, doing my arithmetic here, 0.63 minus 0.71 And this is a fraction, so on a calculator, you should be doing this, the numerator in parentheses, 0.63 minus 0.71, there's the numerator, divided by 1.5 minus 1.3, or 0.2. Oh, and that needs to be in parentheses also. So you want to do your parentheses on your numerator and your denominator to get this to come out right. This number is negative 0.4 times 2 times, now what's this number? Parentheses, 0.67 minus 0.74 divided by parenthesis, 1.5 minus 1.3, close parenthesis. This number is negative 0.35. So we got negative times negative, it's positive, but I'm just going to use that times 2 times negative 0.4, and I get 0.28 is the derivative of this at 1.4. It's the slope of, it's a good estimate for the slope of the tangent line to this function. Bonus question. If you're going to do arc sine, you write down, you start with y equals sine x. Then you swap the y and x, and you get x equals sine of y. You take the derivative, and derivative of x is 1. The derivative of sine is cosine y times, since that's not an x, it's times dy dx. Divide by cosine y. You go back to here, draw a triangle where the angle is y and the sine is x to 1. So this side is the hypotenuse squared minus leg squared, 1 minus x squared. And now we got to figure out the cosine of y, and the cosine of y is adjacent over hypotenuse, so it's this over 1 goes here, so it's 1 over the square root of 1 minus x squared is the derivative of, and what's this? Well, if we solve for y, it's arc sine x. So the derivative is this. This is the steps to get to there.